Well, welcome back. You made it through the first part of the problems where we're just solving the equations. So the last 5 questions on the notes are dealing with word problems and setting up a scenario for each one. So we're going to use the same techniques as we did before, but we have to figure out how to set up these equations. So each problem kind of has its own different scenario. They're all a little bit different in how we set them up. So let's look at number 6. Julia has made 12 free-throw attempts out of 26 in her basketball games this season. If she can raise her free throw percentage to 60%, she will tie her record from last season. How many consecutive attempts will she have to make in order to reach a free throw percentage of 60%? Well, this is, of course, implying that she's not at 60% yet. And this problem can really be done without setting up an equation. So let me just informally introduce that for you first before we get the equation you're required to write down on paper. So if you do like 12 out of 26, you can just, test that in your calculator. You can do 12 divided by 26. That's 0.46. That means she's at about 46%. Well, our goal is to get that up to 60%, right? So let's say she's got 12 out of 46, or 26, which is, that's about 0.46. We want that to be up to 60%. So let's say, well, if she has to make a certain amount in a row to increase that. You understand? You can't just make one and then miss one and make one because her percentage's not going to increase. So it had to be like 13 out of 27, 14 out of 28, 15 out of 29, and so forth. Okay, and so you can, play around with that. You can see if I do that, that's a little bit higher. Well, we're at 50%. 16 out of 30 is 53. We're almost there. And 0.6 is 60%. So the answer to the question would be, how many consecutive attempts will she have to make in order for her to reach a free throw percentage of 60%? Well, she started with having only made 12, and she needs to get up to 21. Well, 21 minus 12 is 9. So she'd have to make 9 more shots in a row to be able to get that percentage. So the answer to the question is 9. Now, here's how you write that as a problem, okay? You would do 12 out of 26, but we're going to add x, because remember on the bottom, I'm just adding the same number as I am the top. So the denominator and numerator are going to both have an x added to them. And I want that to be equal to 60%. Well, 60% is 60 out of 100, or you can think about it as 0.6. This is a little bit up to debate on how you want to set that up. But if I do 0.6, or 0.6d over 1, then really what I'm doing is I'm multiplying the 26 plus x times 1. I mean, the denominators are different, but I can treat this as a proportion. I'm not going to sit here and try to match common denominator, just when I can just set it up like this. So it's going to be 1 times 12 plus x equals 0.6d times 26 plus x. And of course, that's 12 plus x. And I don't know 0.60 times 26 off the top of my head, so of course I'll use a calculator. So that's 15.6 plus 0.60x. All right, so I'm going to want to get the x's to one side. Probably what I want to do in this situation is subtract the 12. Get that subtracted first. So that's going to be x equals, that's 3.6 plus 0.60x. And then I want to subtract the 0.60x from the 1, that's a 1x. So, well, 1 minus 0.6 is 0.4. You can test that here. So that's going to be 0.4x, or 0.40. I guess what's left over from 60% is 40%. So 0.40x equals 3.6. And if I divide both sides by 0.40, you're going to get whatever your answer is. So if you do 3.6 divided by 0.4, that ends up being 9. So your answer to that question is 9, and that's what we verified, when we just were trial and error, guessing and checking. We got 9 that way too. So this is a little bit quicker method. We don't have to sit there and guess and check each time. But 9. So the answer to the question is, of course, how many consecutive attempts? That would be 9 consecutive attempts. So we'll go ahead and write that and box that in. That is the answer to your question. So just look at, when it's one of these out of, keep in mind that that is going to be division, okay? So 12 out of 26 is going to be out of 60%. You can just write there as 0.6. And that's the main idea here. We want to get that up to 60%. Okay, this is what we call a work problem here. You might want to jot that down. You might see that word come up. So this is a work problem. Let's read through it first. Mo and Marco deliver a regular order to a specialty food store. Mo can unload the truck in 40 minutes if he works by himself alone. Mo and Marco can unload the truck in 15 minutes if they work together. So this is some key stuff here. They got alone and they got together, and of course it's going to take them less time working together. How many minutes does it take Marco to unload the truck if he works alone? We got to assume a few things. We got to assume both men work at steady rates. Now, one might work faster than the other, but we got to assume that they're working at the same pace for what works for them. Their rates are not affected by either working alone or working together. So, that's a bit of a stretch, but in order for us to solve that problem, we do have to think like that. So let's interpret this problem a little bit first. So we got Mo. What's going on with Mo is he can unload the truck in how long? It takes him 40 minutes. Okay, let's look at Marco. We're trying to figure out, the question is how long, or how many minutes does it take Marco to unload the truck if he works alone? So we don't know how long it's going to take him to unload one truck. So we're going to go ahead and put that as X. What we do know is that both of them can do it in 15 minutes. So they can do one truck in 15 minutes. So we're actually going to set up an equation that looks like this. We're going to do Mo, we're going to do his one truck to 40 minutes. This is Mo. We're going to do plus, because we want Mo works with Marco. So Marco can do his one truck in some unknown amount of time. And we know that both of them, so we'll say together, which is our equals, is going to be one truck, and it takes them 15 minutes. So we can figure out Marco's pace by solving this equation. Now this is going to be solved using the same techniques as we did with questions 1 through 5. This is an irrational equation, so we look for common denominators. We have a 40x and 15, and the 40, this needs an x and a 15 with it, so I'm going to go ahead and write 15x next to that 1 and 15x next to that 40. This x needs a 40 and a 15, so I'm going to write 40 times 15. And this 15 needs a 40 and an x, so I'm going to write 40x and 40x. Don't worry about restrictions. It's not going to be one of these problems where there's going to be any extraneous solutions. So let's just look at the numerator. We have 15x times 1 plus 1 times 40 times 15 equals 1 times 40x. No, you don't need to write the 1s, so this is really just 15x plus, let's see, 40 times 15, well, that's going to be, let's double check that. $600. Guess I could have figured that out in my head. Equals 40x. So hopefully this is a pretty straightforward equation. I would subtract the 15x from the 40x. And that's going to give you 25x. So 600 equals 25x. Divide out. And 25 actually goes into 600 evenly. That's going to be 24, I believe. So what is this 24? That's the amount of time it's going to take Marco to work by himself. That's the amount of time it takes Marco to work by himself. All right, number 8 is very similar. If you want to pause that and try that one out on your own. If you need some additional help with this one, just follow along and we'll do it together. All right. So what do we got? We got a new street machine can sweep a town street in 20 fewer hours than it takes the old machine. Working together, the two machines can complete the job in 24 hours. How long does it take each machine to complete the job working alone? Assume the machine's rates are not affected by whether one machine is being used or both machines are being used. So let's kind of look at what we got. A new street machine can sweep a town street in 20 fewer hours than it takes the old machine. Well, let's start with the old machine. Okay. It takes one street and we don't know its time. So we'll just call it X amount of, what is it, hours. So X hours. Now let's talk about the new. New one's going to be faster. It's going to clean that street. And it says 20 fewer hours. So the new is 20 fewer hours than the old. So that's going to be X minus 20. And together, it's going to clean one street. And I believe it said 24 hours. So working together, that both, it's going to take them 24 hours. So let's set up our equation. We got the old, we got 1 over X. We got the new. That's going to be 1 over X minus 20. And we got the both. That's going to be 1 over 24. All right, let's get some common denominators. So this has an X, X minus 20, and 24. This means that this X is going to need a 24 and an X minus 20. I'm just going to write it there because I'm not really using the denominators. I'm just going to say times 24. Oops, that's not 20, not a 2. Times X minus 20 times 1. The new one needs an X and it needs a 24. So 24, let me write that as 24x. And then the both one is going to need X and an X minus 20. It's got the 24. So X minus 20. And so let's make sense of this equation. So we got 24x minus 20. Again, I'm just looking at the numerators. Don't worry about restrictions. And that's going to be plus 24x, because that's just a 1, equals x minus 20. And if I distribute that out, that's going to be 24x minus 20 times 24 is, goodness, 480. 24x, this is going to be x squared minus 20x. And that'll combine to 24x minus 480 plus 24x. These are to combine to 48x. So 48x minus 480 equals x squared minus 20x. So it looks like I'm going to need to move, these two over here since that's a quadratic, and then I'm going to make that equal to 0. So if I subtract 48x from both sides, that's going to give me negative 20x minus 48x. And then I'm going to add 480. So negative 20 and negative 48 combine to negative 68. So let me clean this up a little bit. This is going to be x squared minus 68x plus 480 equals 0. And we're going to have to factor this out. So it's going to factor to oh gosh, 480. What multiplies to 480 and adds to 68? We're just going to have to figure this out. Let's see, does 20 go into it? Okay, 20 is a little bit, 20 and 24 don't give you 68. Let's see, 40. Let's see, maybe 60. 60 and 8. So that works. This is a little trial and error, but you end up getting, since that's a minus, it's going to be x minus 60 and x minus 8 equals 0. So again, you can clarify negative 60 times negative 8 gives you 480, and negative 60 plus negative 8 is your negative 68. All right, so x would equal 60 and x equals 8. Now I have two solutions, so how do I interpret that? Well, let's look at the problem first. So what does x represent? X is the number of hours it takes for the old street cleaner. Now let's look at this in context of the problem. If the old street cleaner took 8 hours and the new street cleaner takes 20 fewer hours, well, that just doesn't make sense, right? It can't be 8. So that means that 60 is going to end up being what the old one is. So the old one is 60 hours. And the new one is going to be, well, 60 minus 20. Well, that's going to be 40. So 60 hours and 40 hours. Now that was a bit trickier than number 7, but it's the same type of setup. It's just it has more factors involved, so it does get a little more complicated. All right, let's pause the video and try number 9. All right, if you need some help with number 9, just follow along and we'll go through this together. Serena drove 54 miles in the city, averaging 24 miles per gallon. So let's talk about what we got going on. We got in the city, it takes her 24 miles per gallon, 54 miles of driving. Then she drove 251 miles on highway. So we got city and we got highway driving. Well, let's break this up for a minute. Okay, so in the city, it's 54 miles for those 54 miles, she drove 24 miles per gallon, if that makes sense. On the highway, she drove 251 miles. And it doesn't give us additional information. So let's look at the next part. For the entire 305 miles, so that would be the whole thing, the entire, she 305 miles. She averaged 30 miles per gallon. So 30 miles per gallon. What was the average fuel consumption rate on highways in miles per gallon? So we don't know this, the bottom of the 251. So we have the city, the highway, and then of course the entire is the both. That's going to be the right side of your equation. So let's look at our equation. It's going to be 54 over 24. There's your city. Plus 251 over x, there's your highway, equals 305 over 30. And there's your both. So let's carefully get all of our denominators matched up so we can get this done. This is going to be, let's see, I need a 24x and 30. So this needs a 30x. Let's see, 30x times 54. This one needs a, well, it has the x, so it needs a 24 and a 30. And the 305 over 30, that needs a 24 and an x. So let's write our equation. We have 30x times 54. Plus, the three numbers multiply together, 251 times 24 times 30 equals 305 times 24x. So let's use our calculator and figure out these numbers. So 1620x holy cow, plus 180720 equals 7320x. Now these are big numbers, but I promise you when you work this out, you're going to get more manageable things. I'm going to have to subtract the 1620x from both sides. So let's see what that gets us. We got 180720 equals 7320 minus 1620, 5700x. And I'm running out of room. So x should be whatever 5700 or 180720 divided by 5700 equals. And let's see what that is. 180720 divided by 5700. And it's a decimal. So we'll just have to round that up. It doesn't say what to round it to, so usually miles per gallon. Just one decimal point's fine. So 31.7 miles per gallon. So that's how you do it. So that's going to be her highway driving. So let me label that here. That's going to be highway. Since the question wants to know what is her average fuel consumption rate on highways? 37.1 miles per gallon. And of course that should make sense. If you think about it, most cars, at least standard cars, will get less fuel economy in the city than the highway. But hybrid cars are the opposite. Fun fact. All right, one more question, and then we'll be wrapped up with these word problems. If you want to pause it and try number 10, go for it. If you need one more additional question for some guidance, follow along, and we'll get it done. Okay, question number 10. How much pure acid must be added to 50 milliliters of a 35% acid solution to produce a 75% acid solution? This is a nice little chemistry problem. I guess to visualize what's going on, you have a solution. Let me draw a little beaker. I'm a terrible artist, but I can draw a cylinder. So you have a beaker and you have 50 milliliters of this solution. So in the solution you have 50 milliliters. Now of that 50 milliliters, it says 35% is acid. So how do you figure out what's not acid? Or what is acid and what's not? Well, if you do 0.35 times 50, that part is the acid percent. So of that 50 milliliters, 17.5 milliliters only is acid. So that's kind of like, let's say the bottom portion of this is acid. So think about it like that, okay? This is where the liquid stops. This is where the portion of it that's acid. We want to get this to produce 75% acid solution. This is kind of almost like the problem where we were doing free throws, okay? How much more, if I just add pure acid to this, so pretend my beaker is taller, and I just want to know, all right, how much more acid do I got to add so that gets up to 75%, you know, so it's a bigger portion of it. Well, what's going to end up happening is if you think about 17.5 out of 50, you know, that's your 35%, right? If I say, all right, well, let's say add another milliliter, that's 18.5 out of 51. Well, that increases it, 19.5 out of 52. You know, we want to get this up to 75%. Well, certainly we don't want to keep adding. So, and like example number 6. So look at number 6. We want to add a certain amount to both the numerator and the denominator to get this up to 75%. Okay, does that look familiar to number 6? And we can figure out, all right, well, if I cross multiply, I'm going to get 17.5 plus x would be equal to 0.75 plus times 50 plus x. And if I distribute that 0.75, what is that? That's 37.5 plus 0.75x. So now let's solve. Well, I'm going to subtract from both sides the 17.5. And that's going to give me x equals, hey, that's 20 plus 0.75 x. And then, well, that's 1x, right? So that's 1x minus 0.75. Well, 1 minus 0.75 is 0.25. So that's going to be 0.25 if I subtract that. So 0.25x equals 20. And divide that out. And 20 divided by 0.25 is 80. All right, you know, 0.25 is 1/4. So that's really like 20 times 4, if that makes sense. So x should be 80. 80 what? Well, that's 80 milliliters of pure acid added to the solution. So my answer is 80 milliliters of pure acid added to solution. And let's verify that. So if I add 80 milliliters of liquid to the 50, of course, that's going to be 130. And if I add 80 to the 17.5, that's 97.5. And if I divide that by 130, that's 0.75, that's 75%. Or another way to look at it is you got 17.5 plus 80 divided by our original 50 plus 80, and that's 0.75. So we're adding 80 to the numerator and denominator to get that up to 75%. So that concludes this lesson. It was a long lesson, and you can work out numbers 11 through 18 now on the assignment. Thanks for watching. If you have any questions, please ask in class.